Hey, good morning, students. In the class, we are going to discuss about the direct delta function. The direct delta function. The direct delta function. For any positive number, epsilon, define the function, define the function delta epsilon by letting delta suffix epsilon of t equal to 1 by epsilon if 0 less than or equal to t less than or equal to epsilon, and then 0 if t is less than 0 and t greater than or equal to epsilon. If we are shifting delta E A unit to right, we have delta epsilon of t minus a, which is equal to 1 by epsilon if a less than or equal to t less than a plus epsilon, and then 0 if t less than a or t greater than or equal to a plus epsilon. The function delta epsilon of t, the function delta epsilon of t can be expressed in terms of the Heaviside function See, in the last class, I explained about that Heaviside unit step function and then the problems based on Heaviside function. Already we have discussed it. So, how to write that the direct delta function in terms of Heaviside unit step function is delta epsilon of t equal to 1 by epsilon h of t minus h of t minus epsilon, or delta epsilon of t minus a equal to 1 by epsilon h of t minus a minus h of t minus a minus epsilon. So here, how to draw the diagram for that direct delta function. So delta epsilon of t minus a is y axis, x axis is t, x-axis is t. If you're taking that a here, this point is a plus epsilon. This point is a plus epsilon. Case 1 by epsilon is here. The y-axis 1 by epsilon is here. Then so up to a plus epsilon only, up to a plus a to a plus epsilon only, the 1 by epsilon is there. Afterwards it is 0. So 1 by epsilon means here 1 by epsilon, a to a plus epsilon. Here only it appear. Then otherwise the AB side, sorry, direct delta function will not be there, not exist. So this is t less than a, it is t greater than a plus epsilon. If you're taking the Laplace transform on both sides, taking Laplace transform on both sides, taking Laplace transform on both sides, we get Laplace transform of delta epsilon of t minus a equal to, if you are taking Laplace transform on both sides, what do you get? 1 by epsilon, 1 by epsilon, Laplace transform of h of t minus a, Laplace transform of h of t minus a. So what is Laplace transform of h of t minus a? Already given the formula, minus Laplace transform of h of t minus a minus epsilon. So that is equal to 1 by epsilon. What is the Laplace transform of Heaviside unit step function? What is the Laplace transform of Heaviside unit step function? Able to remember? Laplace transform of Heaviside unit step function. H of t minus a equal to e power minus as. Is it not? Sorry, 1 by s e power minus as. 1 by s e power minus as. 1 by s e power minus as minus 1 by s minus 1 by s e power minus a plus epsilon into s. Therefore, e power minus, if you taking that e power minus a is outside by epsilon, and then 1 by s also you can take it outside, 1 minus epsilon s, 1 minus e power minus epsilon s. Now we define delta of t equal to limit epsilon tends to 0, epsilon tends to 0, delta epsilon of t or delta of t minus a, limit epsilon tends to 0, delta of t minus a. Therefore, Laplace transform of delta of t minus a equal to delta of t minus a equal to limit epsilon tends to 0, limit epsilon tends to 0, e power minus as 1 minus e power minus epsilon s by epsilon s. If epsilon tends to 0, what happen? 0 by 0 indeterminate form. Then if you are differentiate in numerator and denominator, you will get that Laplace transform of delta of t minus a, Laplace transform of delta of t minus a equal to e power minus as, because limit epsilon tends to 0, this 1 minus e power minus epsilon s by epsilon s, this is tends to 1. Okay, it means this value tends to 1 when limit epsilon tends to 0. So you will get that only e power minus a is there. So Laplace transform of delta of t minus a equal to, thus the Laplace transform of, if you substituting a equal to 0 on both sides, Laplace transform of delta of t equal to 1. So Laplace inverse, if you taking that Laplace inverse of e power minus as equal to delta of t minus a. It is one important result. It is one important result. There is one more important result. Three important results are there. Find the Laplace transform of t square delta of t minus phi delta of t minus phi by t. How can we do that? It's two problems. So how can we solve that? T square delta of t minus phi. What is Laplace transform of t square delta of t minus phi? So what is the Laplace transform of t power n f of t? Laplace transform of t power n f of t equal to minus t power n by ds power n phi of s. It is a formula. So f of t here is delta of t minus phi, where f of t equal to delta of t minus phi. So Laplace transform of f of t is, that is equal to phi of s. That means Laplace transform of delta of t minus phi e power minus as. Here a is 5. So e power minus 5s. E power minus 5s. Therefore, d power n by ds power n, where n equal to 2, na? So d square by, therefore, Laplace transform of d square delta of t minus 5 equal to d square by cs square e power minus 5s. So directly we can write that is 25 e power minus 5. 25 e power minus 5s. Similarly, we can do the second one. When it is divided by t, second problem, problem number 2, delta Laplace transform of delta of t minus 5 by t. We know that L of f of t by t equal to integral of s to infinity phi of s ds. So what is phi of s here? Integral over s to infinity Laplace transform of delta of t minus phi ds. That is integral over s to infinity e power minus phi s ds. So e power minus phi s by minus pi from 0 to infinity. That is, sorry, not 0, s to infinity. That is e power minus pi s by pi is the answer. Laplace transform of periodic function. Laplace transform of periodic function. First, what is called a periodic function? The function f of x is said to be periodic with period t if the function of x plus t equal to, we will get f of x. So period mean t, 2t, 3t, etc. It may come. What is the smallest integer of this period is called? That means once again it comes to the same question. For example, sin x and cos x are the periodic function with the period 2 pi. with the period 2 pi. Similarly, tan x is the periodic function with pi. Period pi. What is the Laplace transform of the periodic function? If f of t is the periodic function with the period a, then the Laplace transform of f of t equal to 1 by 1 minus e power minus as integral over 0 to a 1 minus e power minus as, I think is correct. Yes, 0 to a e power minus st f of t dt. See, only already you know this formula. Integral of 0 to infinity e power minus st f of t dt. Okay, it is a Laplace transform. But the Laplace transform of the periodic function is 1 by 1 minus e power minus as 0 to whatever the period you have to write. 0 to a e power minus st f of t dt. Easily you can remember this formula. This is important MCQ. Fine. Laplace transform of the rectangular wave and the Laplace transform of rectangular wave given by f of t equal to 1, 0 less than t, less than p, minus 1, p less than t, less than 2b, with the f of t plus 2b equal to f of t. How can you say it is the rectangular wave? If you draw the graph for this, see, it is a periodic function. So 0 to p, b to 2b, 2b to 3b, 3b to 4b. Just continue like this. So 0 to b, in case b here, 2b here, 3b, 4b, 5b, 6b. So 0 to b, it is 1. 1 here, y equal to 1, y equal to minus 1 here. So these are rectangular wave, na? Actually, it is very useful in the signals and systems. The electronics people's, this in electronics engineering, this rectangular waves, the application of rectangular waves is much important. This is called the rectangular wave. How to find the Laplace transform of the periodic function? Here the period is 2b. The period is 2b. Period is 2b. So what is the Laplace transform? Laplace transform of f of t equal to by e power 1 minus e power minus as. Now a is 2b here. 2b is integral over 0 to 2b e power minus st f of t dt. So 1 by minus e power minus 2bs 0 to b 0 to p e power minus st f of t is 1 dt plus b to 2b e power minus st f of t is minus 1, so minus here dt. That is equal to 1 by minus e power minus 2bs e power minus st by minus s minus e power minus st by minus s. It is from 0 to b, it is from b to 2b. So 1 by 1 minus e power minus 2bs. So what is the next step? One by divided by s we can write here. Divided by s we can write here. 1 minus 2 e power minus bs minus e power minus bs whole square we can write. So plus. So it is like a square minus 2ab plus b square format. So we can write this as 1 by 1 minus e power minus ps whole square. 1 minus e power minus ps whole square. So here 1 by s 1 minus e power minus ps whole square. This can be written as 1 plus e power minus ps 1 minus e power minus ps we can write. That is a square minus p square format. So 1 minus this get cancelled. So 1 by s 1 minus e power minus ps na. So 1 plus e power minus ps. Find the Laplace transform of find the Laplace transform of the half wave rectifier function. Half wave rectifier function. Half wave rectifier function f of t equal to sin omega t 0 less than t less than pi by omega Am I audible?
Yes, sir.
Okay, fine. See, sin omega t, 0 less than t less than pi by omega, and then 0 pi by omega less than t less than 2 pi by omega. 2 pi by omega with f of t plus 2 pi by omega 2 pi by omega equal to f of t. So here what is the period? What is the period here? Ah, what is the period here?
2 pi by omega.
Period is 2 pi by omega. So here, how to draw the diagram for this? Pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. Okay. At the peak, if you are substituting that sine omega t, y equal to pi by omega here. So sine pi 0. Okay. Maximum value is in case if it is pi by 2. So case if it is pi by 2 means pi by 2 omega. So t by 2, pi by 2, sine pi by 2 maximum 1. So maximum value is 1 and then minimum value minus 1 here. But minimum value you will not get. So this is 1 f of t. This is f of t. Here t. T is it not? So 0 to pi only sine will come. If it is 1, then it is half sine wave rectifier function. Half sine wave rectifier function. The remaining is 0. The function is sine for 0 to pi, 2 pi to 3 pi, 4 pi to 6 pi pi. Okay. So how to solve this? The Laplace transform of f of t equal to 1 by e power 1 minus e power minus as. So here a is 2 pi by omega. 2 pi by omega s integral over 2 pi by omega f of t dt e power minus st f of t dt of t dt. Just 1 minute wait. Here, so how can you calculate this? 1 by 1 minus e power minus 2 pi by omega 2 pi s by omega integral over 0 to pi by omega e power minus st sin omega t dt plus remaining is 0. So e power minus st sin omega t dt. What is integral over e power minus at sin bt dt? Formula. What is the formula? E power minus at sin bt dt. Anybody? E power minus at by a square plus b square a sin bt minus b cos bt. So if you are solving this, you will get 1 by 1 by 1 minus e power minus 2 pi s by omega 2 pi s by omega omega into I'm writing, I'm skipping 2 or 3 steps after, then that is you have to integrate, apply this formula, then you will get this step 1 plus e power minus s pi by omega divided by s square plus omega square so finally you will get that omega divided by 1 plus e power minus pi s by omega into s square plus omega square is the answer for that Laplace transform of f of t. Actually in middle I skips 3 steps. You have to do that. Please don't skip the step. You have to do that. I skip 3 steps in middle. You have to do that. Apply the formula. Find the Laplace transform of the periodic function. Am I audible? Am I audible?
Yes, sir.
Okay. Find the Laplace transform of the periodic function. Find the Laplace transform of the periodic function. F of t equal to t for 0 less than t less than 1, 2 minus t for 1 less than t less than 2, where f of t plus 2 equal to f of t. How to do this? Here, how to draw this? 0 to 1, this continues like this. So 1 here, 2 here, 3, 4, 5. Only thing is you should know how to draw the diagram for the given function. Okay. So here f of t, this is t. Okay. So here 0 to 1 is t, 45-degree straight line. Okay. 2 to 1 to 2, in case if you are writing f of t is y na, y axis, y equal to 2 minus x like that. But you can write that x plus y equal to 2. X by 2 plus y by 2 equal to 1. What is this? What is this? X by 2 plus y by 2 equal to 1. Parabola? Ellipse? Hyperbola? Huh?
Straight line, sir.
Straight line which form? Straight line is correct. Which form? Straight line is okay. What is the form of the straight line?
Intercept form, sir.
Intercept form. What are the intercept here?
2, 2, sir.
2, 2. So if you taking 2 here, then approximately we can draw. So this is intercept form. Therefore, the function is, so how can you draw the diagram? This is the diagram. So once again, this is the diagram for the function, triangular function. This is a triangular function. First we have seen that rectangular function. Second one, half sine wave rectifier function. Third one is triangular function. These functions are much more important in the electrical and electronic field. Okay, fine. So how to find that Laplace transform? So that's why the signals and systems in the ECE students mostly use that Laplace transform and Fourier transforms in their calculations. Okay, the application of Laplace, particularly the application of Laplace transform and Fourier transform, is to solving that ordinary differential equation and partial differential equation. Okay. How to solve this? E power Laplace transform of f of t equal to 1 by 1 minus e power minus as integral of 0 to a e power minus st f of t dt. So here a is 2, period. A equal to 2. So 1 by 1 minus e power minus 2s integral over 0 to 1 t dt, sorry, e power minus st t dt plus 1 to 2 e power minus st 2 minus t 2 minus t dt by 1 minus e power minus 2s e power minus 2s e power minus st t dt na, you are applying the Bernoulli's formula here. T e power minus st by minus s minus 1 e power minus st by s square. It is from 0 to 1 plus 2 minus t e power minus st by minus s minus 1 1 to 2. One by minus e power minus 2 was substituting 0 to 1 here, 1 e power minus st by minus s e power minus st by minus s st வராதுல்ல e power minus s by minus s t is 1 minus e power minus s by s square. 0 means plus 1 by s square. 2 minus t means plus 0 minus minus plus e power minus 2s by s square. 1 substituting 1 means 2 minus 1 1 minus 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 plus e power minus s by s, and substituting 1 lower limit minus e power minus s by s square. So e power minus s by s, e power minus s by s get cancel. So 1 by 1 minus e power minus 2s. It is like 1 minus e power minus s whole square by s square. Directly I am writing because it is like a square minus 2ab plus b square, because here e power minus s, e power minus s minus 2 e power minus s. So 1 minus e power minus s whole square by s square. This can be written as 1 plus e power minus s, 1 minus e power minus s, 1 by 1 minus e power minus s whole square by s square. 1 minus. So that get cancel. Then this 1 minus e power minus s can be written as 1 minus e power minus s by 2, e power minus s by 2 divided by 1 plus e power minus s by 2, e power minus s by 2, 1 by s square. So you can write this as, if you are taking to the denominator, taking s by 2 to the denominator, e power s by 2 minus e power minus s by 2 divided by e power s by 2. If you are taking to the denominator, e power s by 2 plus e power minus s by 2 by e power s by 2 into 1 by s square. That e power s by 2, e power s by 2 cancel. Then it is 2 sin h s by 2, 1 by s square, 2 sin h s by 2, 2 cos h s by 2, 2 get cancelled. So answer is 1 by s square tan h s by 2. This is very important result. Can you rub the board? Did you complete it? Did you complete it? Can you rub the next topic is inverse Laplace transform. Inverse Laplace transform. The inverse Laplace transform formulas is denoted by L inverse 1 by S minus A equal to e power AT. L inverse of 1 by S plus e power minus AT. Third one is L inverse of 1 by S square plus A square. 1 by A sin AT. L inverse of S by S square plus A square is cos AT. L inverse of 1 by S square minus A square is sin AT by A. L inverse of S prime S square minus A square is cos H AT. Cos H AT. L inverse of 1 by S by S is 1. Similarly, L inverse of 1 is delta epsilon of 2. L inverse of S power n plus 1 e power n by n factorial. Find the Laplace inverse of 1 by S minus 3 plus 1 by S plus S by S square minus 4. So if you are finding that L inverse here, L inverse of 1 by S minus 3 plus L inverse of 1 by S plus L inverse of S by S square minus 4. So it is e power 3t plus 1 plus cos H2. That is f of. Similarly, second problem. Find the Laplace transform, inverse Laplace transform of 2s 2 divided by 2s minus 3 plus s by s square plus 1. So if you want to solve this, L inverse 2, keep it, and then it should be that s minus a is plus a like that. So taking the 2 outside, so we'll get that s minus 3 by 2 plus s by s square plus 1. This 2 get cancelled. So e power 3 by 2t plus cost. This f of t. First shifting property. First shifting property. First shifting property. What is first shifting property? Laplace transform of e for at f of t equal to f of s minus k na. Therefore, this phi of s minus a. So e power at f of t equal to Laplace inverse of phi of s minus k. Similarly, e power minus at f of t equal to Laplace inverse of phi of s plus a. So using this, find the value of or solve Laplace inverse of 1 by s plus 1 whole square. L inverse of 1 by s plus 1 whole square. It is like that phi of s plus a format. So we have to take that e power minus at f of t. That means what is f of t here? E power minus s f of t. F of t is L inverse of phi of s. So what is phi of s? If you are taking that s plus 1 as s, then 1 by s square. So e power minus s L inverse of 1 by s square. So e power minus at na, not s. T. E power minus t is f of t na. So t e power minus f of t is t e power minus t. Find Laplace inverse of 1 by s plus 1 whole square plus 1 to L inverse of s minus 3 by s minus 3 whole square plus 4. L inverse of s by s plus 3 whole square. solve these problems. So here in the first problem, if you taking that s plus 1 plus 2s, then e power minus t L inverse of 1 by s square plus 1. So that is e power minus t sin t. First problem. Second problem is s minus 3 plus 2s na. So e power 3t L inverse of s by s square plus 4. So e power 3t cos 2t. Before you come to the next class, please you go through the partial fraction. Everyone, I think everyone is knowing that e power 3. Third one is L inverse of s by s plus 3 whole square na. So s plus 3 times 2s and s plus 2s minus 3. So e power minus 3t L inverse of s minus 3 by s square. So e power minus 3t L inverse of 1 by s minus 3 by s square. So e power minus 3t 1 minus 3. Please stop the recording.